Imagine giving an AI coding agent one clear instruction: inspect a shop, sign in, apply a discount, complete a test order, and prove that every important result is correct. The agent opens a real browser, reads the interface, chooses accessible controls, watches the network, downloads a receipt, and then turns that explored journey into a repeatable Playwright test. That is the workflow we are building in this course. This is not a slideshow about browser automation, and it is not a collection of unexplained prompts. You will see the browser, terminal configuration, source code, test report, and trace evidence working together. Our target is MCP Commerce Lab, a deterministic application created for this tutorial. It has 6 products, 5 local API routes, authentication, cart state, a discount rule, checkout, a receipt download, and useful failure paths. Nothing places a real order, and there are no third-party services to make the demonstration flaky. We will first ask the agent to inspect the page without changing it. Then we will complete the main customer journey, deliberately submit an invalid password, intercept network responses, recover from a simulated service failure, and preserve the result as maintainable test code. You will configure the official Playwright MCP server in Codex, Claude Code, and Visual Studio Code. The client screens differ, but the central idea stays the same. A language model reasons about the goal, while Playwright supplies controlled browser tools and structured evidence. I will also show where ordinary Playwright test remains essential. An agent can help explore and diagnose. A committed test suite gives us repeatable assertions, reports, and continuous integration. We will move slowly enough to explain why each step works, then repeat the pattern at production speed so you can recognize the complete agent loop. Every command and prompt used on screen lives in the companion repository. By the end, you will have a working local repository, practical prompt recipes, and a clear mental model for choosing between exploration, debugging, and regression testing. You will also understand the safety boundary. A browser agent may encounter page content, cookies, downloads, and authenticated sessions, so we will use isolated test data and review every capability we enable. Start by watching the completed journey. The Playwright Field Guide costs £24.99. The agent signs in as Alex Lerner, adds the guide, applies MCP 20, confirms the total is £19.99, places a demonstration order, and verifies the generated order identifier. That visible outcome is useful. The network request, downloaded receipt, and automated assertion are the evidence. Let us build the whole chain from first principles. Before installing anything, let us separate the parts of the system. MCP is the Model Context Protocol, a standard way for an AI application to connect to external capabilities and context. In MCP terminology, Codex, Claude Code, or Visual Studio Code acts as the host. Inside that host, an MCP client maintains the connection to a server. The Playwright MCP server is the external provider in this diagram. It exposes browser operations as tools and returns structured results the model can reason about. The language model does not become Playwright, and Playwright does not decide what business outcome matters. The model plans, the server operates the browser, the host manages the conversation, permissions, and tool exchange. Follow one instruction through the architecture. We ask, open the local shop, inspect the main journeys, and do not place an order. The host sends the available tool descriptions and our request to the model. The model can choose a navigation tool. The Playwright server launches or connects to a browser, loads the page, and returns an accessibility snapshot. The model reads headings, links, buttons, forms, and live status text from that structured representation. It can then explain the journeys without guessing from pixels. If we later authorize a click, the model selects an element reference from the current snapshot, the server performs the action through Playwright, and the updated state comes back to the model. That loop is important. Reason, call a tool, observe the result, and reason again. Element references belong to the observed page state. When navigation, a modal, or a dynamic update changes the interface, take a fresh snapshot instead of treating an old reference as permanent. Screenshots are still valuable for visual review, but the normal structured workflow does not require a vision model to infer where a button sits. This makes the interaction more inspectable and often more precise for semantically well-built pages. The host may render the exchange differently, yet the underlying sequence remains recognizable. The server can expose more than the core navigation and interaction tools. Capabilities may add network inspection, storage operations, testing helpers, and developer tools. We enable selected capabilities explicitly in this repository because every extra surface should have a reason. MCP is a transport and tool contract, not a security boundary. A powerful browser connected to a signed-in profile can reach whatever that profile and environment can reach. Keep this division of responsibility in mind throughout the course. Prompts describe intent and constraints. Accessibility and network observations supply evidence. Playwright executes browser operations. Playwright test turns stable discoveries into code. The human still chooses the environment, approves access, defines success, and reviews the result. Now let us tour the repository we will use from beginning to end. The application is deliberately local and deterministic. Public demonstration sites change, throttle requests or disappear, which is poor material for a detailed course. MCP Commerce Lab gives us realistic browser behavior without those external variables. The server is a small Node application. Its public folder contains the accessible interface, styling, and client-side state. It also provides local endpoints for health, products, login, discounts, and orders, plus a receipt download. These routes let us demonstrate user interaction and network evidence against one controlled system. Open the home page at 127.0.0.1, port 4173. The hero describes our working method: inspect, act, prove, and maintain. Below it, the catalog contains 6 products with headings, descriptions, prices, ratings, and add to cart controls. The search input and category selector call the product endpoint. The account dialog accepts only the local course credentials. The cart stores state in local storage, accepts the MCP 20 discount, and calculates the visible total. Checkout requires a name, UK test address, delivery choice, and an explicit acknowledgement that this is a demonstration. A successful order returns a lab identifier and a receipt link. The tests folder contains shop.spec.ts. Its current cases cover catalog filtering, invalid authentication, discounted checkout and download, product API mocking, and capture of the order request payload. Notice the Locator style. Tests ask for a heading by name, a search box by its accessible label, or an article containing the product title. These describe what a user perceives instead of coupling every step to CSS classes. The assertions verify business outcomes such as one product shown, the 1999 total, the error alert, and the authorization header. Playwright.config.ts supplies the base URL and starts the app for the suite. It uses Chromium, emits list and HTML reports, and retains trace, screenshot, and video evidence on failure according to the checked-in policy. The GitHub Actions workflow installs Node.20, installs Chromium with operating system dependencies, runs the tests and uploads the report even when a check fails. Finally, the prompts folder contains the instructions used on screen. Keeping prompts beside code makes demonstrations repeatable and reviewable. The client configuration files sit at project scope .codex/config.toml, .mcp.json, and .vscode/mcp.json. We will inspect each before running it. Treat the repository as a laboratory, one application, one evidence trail, and several AI hosts using the same underlying browser service. Let us install the lab in a way that is easy to reproduce. For this course repository, use Node.js 20 or newer and a current NPM release. Playwright MCP 0.0.78 itself supports Node.js 18 or newer. Confirm both in the terminal with node -- version and npm -- version. Then open the companion repository, run npm install, and install the Chromium browser binary with npx playwright install Chromium. The package lock records the versions used to verify this course: Playwright Test 1.61.1 and Playwright MCP 0.0.78. The client configurations use at latest so that new learners receive the current official server. If behavior changes in a future release, compare it with the lock file and the official release notes rather than guessing. Start the application with npm start. The health endpoint at port 4173 allows both Playwright and us to confirm the server is ready. Open the home page and make sure the catalog says 6 products shown. In a second terminal, run npm test. Playwright's web server configuration can start the same application automatically, reuse an existing local process outside continuous integration, and wait up to 30 seconds for the health URL. The 5 checked-in tests should complete in the Chromium project, followed by an HTML report on disk. At this point, the ordinary Playwright Foundation is working before an AI agent receives browser access. Now install or register the official MCP server in your chosen host. Underneath each client-specific command is the same package invocation, npx-y at playwright/mcp at latest. npx resolves the package, and the -y flag allows the command to proceed without an interactive package install prompt. Do not copy an arbitrary similarly named package. The official project is maintained in Microsoft's Playwright MCP repository, and the npm package name is exactly at playwright/mcp. This course enables the testing, network, storage, and developer tools capabilities, launches an isolated profile, sets a 1440 by 900 viewport, and writes generated evidence beneath artifacts/Playwright MCP. Those options are in the checked-in configuration so that they can be reviewed before use. Isolation gives this demonstration a fresh browser profile rather than borrowing everyday cookies and sessions. It is an operational safeguard, not a sandbox. If the server does not start, work from the bottom up. Check Node, package installation and browser installation. Run the base npx command in a terminal and read its error. Confirm the host is loading the project configuration and trusts this folder. Then list the registered servers from the host. A successful installation means the Playwright server is visible and its tools can be enumerated. It does not yet mean every website or local file should be exposed. The accessibility snapshot is the most important concept in a standard Playwright MCP workflow. It is a structured description of the page's meaningful interface, not a photograph. Open the captured snapshot from our first visit. At the top, we can see a banner, a home link, primary navigation, a sign-in button and a cart button whose item count label is 0. The main region contains a level 1 heading, action controls, and the 4-step workflow. Further down, a search region exposes a search box named Search Products, a combo box named Product Category, and 6 product articles. Each article has a heading, descriptive text, rating, price, and Add to Cart button. This structure is valuable because names and roles express intent. An agent does not need to estimate the coordinates of a small button. It can reason that the user asked for the Playwright field guide, find the article whose accessible content contains that title, and choose the Add to Cart button within that article. That same pattern becomes readable Playwright code. Get the article by meaningful text, then find its button by role and name. A well-designed accessible interface therefore helps human users, browser agents, and maintainable tests at the same time. The bracketed references in the snapshot identify elements for the current tool interaction. In our capture, the hero heading has one reference, the search box another, and each Add to Cart button its own reference. Think of these as handles for the present page state, not selectors to paste permanently into source code. Searching, opening a dialog, navigating or re-rendering content can produce a new tree and new handles. After a material state change, ask for a fresh snapshot and confirm the target still has the expected role, name and context. Now compare the first snapshot with the signed-in capture. The sign-in button becomes an Alex button, and a live region message reports signed in as Alex Learner. That change supplies 2 independent observations of successful authentication. We can still inspect network evidence where needed, but we are not forced to infer success merely because a click returned without error. Snapshots are not a complete replacement for visual checking. Color contrast, clipping, spacing, animation and overlapping elements may require a screenshot or a human review. Canvas-based interfaces can also expose limited semantics. Use the right evidence for the question. For this accessible commerce workflow, begin with the snapshot. Act through meaningful roles, observe the updated snapshot, and reserve screenshots for appearance. If an element is difficult for the agent to describe, first ask whether the application should expose better semantics rather than immediately reaching for brittle coordinates. With the page model understood, let us group the core tools by purpose. First, our navigation and observation. Browser Navigate opens a URL. Browser Snapshot returns the structured page state. Browser Take screenshot records visual appearance, while console and network observations help explain failures beyond the document. Start every unfamiliar journey by navigating and observing. An instruction such as click through the checkout is weaker than inspect the page, identify the journey, then ask before placing an order, because it removes an important evidence step. Second are interaction tools. The server can click a referenced control, type into a field, fill a set of form values, select an option, press a key, hover and wait for a meaningful state. The exact set shown by your host depends on the server version and enabled capabilities. Prefer the highest level operation that matches the user's action. Fill email address with the local account value. Click the sign-in button inside the named dialog. Select Express only when the test requires it. Avoid using fixed delays as proof. Wait for a visible business outcome, a network response, a download, or an accessible status change. Watch this on Commerce Lab. We open Sign In and take a new snapshot. The dialog is named Sign In to continue and contains labeled email address and password fields. We fill the valid course data and submit the exact sign-in button inside that dialog, avoiding confusion with the header control behind it. The updated page exposes Alex and the live status message. Next, we locate the Playwright field guide article, add one item, open the cart, Enter MCP20 and click Apply. We do not assume the arithmetic worked. We inspect the status announcing a 20% discount and the visible total of £19.99. Third are evidence and control surfaces. A download action can be paired with an expected download event. Network tools can inspect requests and responses, while routing can replace a response for a controlled failure or mock. Storage capabilities can inspect or manage browser state when explicitly enabled. Testing helpers can support verification and generation workflows. Developer tool capabilities add deeper diagnostic information. Enable only what the scenario needs and keep the output directory deliberate. A robust tool sequence has a simple rhythm: observe, choose a semantic target, act once, and verify the smallest meaningful outcome. If the page changes, observe again. If an action fails, inspect the current snapshot, console and network, rather than repeating clicks blindly. This is the difference between browser motion and browser automation. Movement is easy. Trustworthy evidence is the actual product. We are ready to connect Playwright MCP to Codex. I will show both a user-level command and the project-scoped configuration used by this course. In a terminal, run Codex MCP add Playwright --npx-y quoted at Playwright/MCP at latest. The double dash separates Codex's arguments from the command that starts the server. Then run Codex MCP list and confirm that a server named Playwright is present. Codex manages MCP servers through the Codex MCP command group and stores user configuration in the Codex config file under your home directory. Review that file if you need to understand what will start in other projects. For a repository-specific setup, open .codex/config.toml in Commerce Lab. The MCP servers.playwright table sets npx as the command and passes the package plus our selected flags. We enable testing, network, storage and developer tools, request an isolated browser profile, set the viewport to 1440 by 900 and place server output under artifacts/playwright MCP. A 60-second start timeout leaves room for first-time package resolution, while the tool timeout is 2 minutes. The default approval mode is prompt, so tool use is not silently treated as harmless. Project configuration is useful because collaborators can review the intended server command alongside the code. It also requires trust. Codex loads project-scoped configuration for trusted projects. Do not mark an unknown repository as trusted merely to make a command run. Read the command, package name, arguments, and any environment variable references first. In our lab there are no production secrets. The target is localhost, and isolated mode avoids reusing the everyday profile. Those choices reduce exposure, although they do not turn the browser into a security boundary. Open Codex from the repository root so the project context is clear. Ask it to enumerate the available Playwright tools before issuing a broad task. Depending on the Codex surface, tool names may be displayed with a server namespace, but their descriptions should make the browser operation clear. Approve only the tools required for the current step. For the first pass, navigation and snapshot access are enough. There is no reason to submit an order while we are simply mapping the site. If Codex does not show the server, verify that you opened the correct folder, that the project is trusted, and that Codex MCP list shows the expected entry. Run the npx server command separately to expose package or node errors. If two configurations define the same name, inspect which scope Codex is applying. Once the server and tools are visible, stop troubleshooting and move to a narrow, observable prompt. Our first Codex task is intentionally read-only. Open prompts /01, explore and plan. It asks Playwright MCP to open the local application, inspect the page using the accessibility snapshot, explain the main user journeys and highest risk business rules, and avoid submitting an order. It also asks for a concise plan grouped into smoke, negative and edge case coverage, with page or network evidence behind each recommendation. This is a stronger prompt than test this website because it supplies a target, a boundary, an output shape, and a standard of proof. Start the app, paste the prompt into Codex, and review the proposed tool call. Navigation to localhost is expected. The first snapshot should expose the hero, navigation, course workflow, search controls, and all 6 product articles. Let Codex summarize what is actually present. A sensible smoke plan includes loading the catalog, filtering products, authenticating with the course account, adding an item, applying the known discount, completing a demonstration checkout, and confirming the receipt. Negative coverage should include invalid credentials, an unsupported discount, an empty cart, and an order service error. Edge cases may include repeated cart additions, category and text filters together, delivery price changes, mobile layout, and session restoration. Now challenge the plan. Which recommendations are visible in the page, and which are hypotheses requiring more evidence? The initial snapshot proves controls and descriptive content, but it does not prove the login endpoint's response shape or the order request payload. Codex should distinguish observed facts from proposed checks. If it needs network evidence, allow the relevant inspection tool and reproduce only the minimum interaction. Do not allow the planning task to place an order simply because checkout exists. Constraints are part of the test. Next, ask Codex to map each high-risk rule to an observable outcome. The MCP 20 rule should map to a 20% status message and a $19.99 total for the $24.99 guide. Authentication should map to the Alex account control and the signed-in live message. Checkout should map to a confirmation dialog, a lab order identifier, an order request, and a receipt download. These mappings become the bridge from exploration to assertions. Save the final plan beside the repository or compare it with the checked-in test suite. Notice what the existing tests already cover and what remains a deliberate extension. This is where an agent is genuinely useful. It can rapidly inventory a semantic interface, connect journeys to evidence, and propose risk-based coverage. Codex has not replaced test judgment. We have given it a controlled browser, precise constraints, and an evidence requirement, then reviewed its reasoning before any consequential action. In the next hands-on phase, that approved plan becomes a real checkout journey and maintainable Playwright code. Exploration is valuable, but a browser session is not yet a regression test. The next step is to turn the evidence we gathered into readable, source-controlled Playwright test code. Open prompts/04 generate test.md. Its instructions are deliberately specific. Prefer role, label, and text locators, assert business outcomes, avoid fixed sleeps, run the result, and inspect the report. Now open tests/shop.spec.ts. The file imports test and expect from Playwright test. Before each hook opens the base URL, clears local storage, and reloads, so every case begins from known cart and sign-in state. That isolation matters because MCP exploration may leave state behind. For the checkout case, begin with page.getByRole, button, name sign in. Scope repeated names to the dialog called sign in to continue, and fill email address and password through their labels. After submission, verify signed in as Alex Learner. That is a user-visible outcome, not a CSS class. Find the correct product by taking the article locator and filtering it with the text Playwright field guide. Within that product card, click Add to Cart. The same pattern stays readable even if the grid is reordered. In the cart dialog, fill discount code MCP20, click Apply, and assert both the status message and the exact total of £19.99. Complete the address form through Labels, tick the demonstration order acknowledgement, and place the order. The confirmation dialog is the durable outcome. Verify it is visible and contains an order identifier beginning Laby 2026. Downloads require one important ordering rule. Create page.waitForEvent, download, before clicking the download receipt link. Await the promise afterwards, then check the suggested file name. This prevents the event from racing past the test. Run only this journey with npx playwright test/shop.spec.ts --grep, completes a discounted checkout. Then run npm test for the entire suite and npx playwright show report for the HTML evidence. The report should show the test title, browser project, duration, and any attachments. A green row is useful, but open the case and confirm it is the journey you intended to execute, not an accidentally skipped or filtered test. Playwright locators and web-first assertions wait for actionable, observable state. A hard-coded timeout merely waits and hopes. Finally, review the generated test as engineering work. Remove redundant steps, keep constants clearly named, and ensure every assertion proves a requirement. MCP helps discover the workflow and propose locators. Playwright test supplies repeatability, isolation, reporting, and a result your team can run in continuous integration. Let us connect the same official Playwright MCP server to Claude Code. Start in the Commerce Lab repository with Node 20 or newer installed. That is the course requirement. Playwright MCP 0.0.78 itself supports Node 18 or newer. Keep npm start running if you want to explore the application immediately. The exact project scoped command is on screen. It begins Claude MCP add, transport standard input-output, scope project, and the server name Playwright. After the double dash, the command executed for the server is npx-y at playwright/mcp at latest, followed by caps testing, network, storage and dev tools, and isolated. The double dash is significant. Everything before it belongs to the Claude command. Everything after it is passed to the MCP server. Project scope writes a shared .mcp.json in the repository. That is appropriate here because the command and non-secret options are useful to every contributor. Claude Code asks for approval before using a project-scoped server it discovers, so read the command rather than approving it on autopilot. Do not place API keys, passwords or session values directly in this shared file. Claude Code treats workspace trust and project server approval separately. A project server may remain pending until you run Claude interactively and approve it. Claude MCP reset project choices resets those server approval choices. Team members should treat this as a fresh executable dependency review, not as an inconvenient dialog to dismiss. Verify the connection with Claude MCP list, then Claude MCP get Playwright. The checked-in configuration should show type standard input-output, command npx, and the same argument array used by Codex and Visual Studio Code. Core browser tools are always available. The 4 opt-in capabilities add test verification and locator generation, network routing and offline control, storage management, plus tracing and video tools. Isolated mode gives this course a clean browser context and discards its session when the browser closes. That is safer for a repeatable lab than silently borrowing your everyday browsing profile. Start Claude Code from the repository and use the first prompt recipe. open the local URL, inspect the accessibility snapshot, explain the main journeys, and return a risk-based test plan without submitting an order. Watch the tool calls. Claude should navigate, read structured page state, and cite concrete elements or requests rather than guessing from the source alone. Approve only the tools that match the task. If the server does not appear, use /MCP inside Claude code, or inspect Claude MCP get Playwright and the server output. On native Windows, local NPX-based servers may need the command wrapper cmd/c. That is an operating system execution detail, not a Playwright difference. We use at latest in client configuration, so new learners receive the current server, while packagelock.json records the exact versions verified for this course. That combination makes the tutorial current and the companion project reproducible. A useful browser agent does more than repeat clicks. It shortens the path from failure to evidence to a minimal fix. We will use the invalid credentials journey because its expected behavior is unambiguous. First, reproduce the test outside the agent with npx playwright test/shop.spec.tease --grep shows a useful error. The configuration starts the local web server automatically, reports to the terminal and HTML, and retains a trace, screenshot, and video when a test fails. For the demonstration, change the expected alert text temporarily so the assertion fails. Do not change the application. Now give Claude the prompt from prompts/03debugfailure.md. It instructs the agent to reproduce the problem, inspect the DOM snapshot, console messages, network requests, and trace before editing code, identify the smallest defensible root cause, and ask before changing ambiguous behavior. This order prevents a common failure mode, seeing a red test and immediately rewriting production code. The browser evidence shows a sign-in dialog, an email address field, a password field, and an alert reading email or password is incorrect. Network evidence shows post/API/login returning 401 for the deliberately wrong password. That status is expected. It proves the server rejected the credentials. It is not, by itself, the defect. The Playwright error then compares the observed alert with our deliberately incorrect expectation. The smallest fix is therefore the test assertion, followed by one focused rerun. If the UI and the written requirement disagreed, Claude should stop and ask which behavior is authoritative. In Trace Viewer, check the action timeline, the DOM snapshot at the failed assertion, console entries, and the associated request. Correlating those views is far stronger than diagnosing from the final screenshot alone. Use the MCP core tools for fresh snapshots, console output, and request history. With the DevTools capability, the agent can also start and stop an MCP browser trace. Keep that separate in your mind from a Playwright test trace. One records the exploratory MCP session, the other is produced by the test runner and appears with test attachments. Both are evidence, but they come from different runs. After the focused case passes, run npm test, then inspect the HTML report or open a failed trace, rather than trusting a conversational summary. Review Claude's diff. One requirement-aligned change is good. Unrelated formatting or application rewrites are not. Revert the deliberate teaching fault so the repository remains green. The repeatable loop is reproduce, observe, explain, change the smallest thing, rerun the focus test, then run the suite. Claude Code contributes fast cross-checking between browser, network, and source. Your test result remains the final authority. Now configure the editor workflow. Visual Studio Code can run MCP servers from your user profile or from a workspace file. This repository uses .vscode/mcp.json, so the team can review one project-specific configuration. Notice the top-level key is servers, not MCP servers. Under Playwright, type is standard input-output, command is npx, and the arguments begin -y at playwright/mcp at latest. The remaining options enable testing, network, storage, and dev tools. Select an isolated browser, set a 1440 by 900 viewport, and send generated evidence to artifacts/Playwright MCP. There are two sensible installation routes. Because this file already exists, open it and use its inline start action, or open the command palette and run mcp:/list servers. Choose Playwright, start it, and review the output if anything fails. mcp:/open workspace folder configuration is the direct command for reopening this file later. A user profile server is available across workspaces. Our workspace server travels with this repository and stays scoped to it. Alternatively, search the extensions view for an MCP Playwright and install the official server into your workspace. Do not confuse the MCP server with the separate Playwright test extension. Both are useful, but they solve different problems. Visual Studio Code normally asks you to trust a new or changed workspace server. However, starting it directly from the inline action in mcp.json bypasses that trust prompt, so review the configuration manually first. A local MCP process can run code with the access granted to it. Inspect the package, command, and arguments before starting it. Next, open Chat, choose Agent from the Agent Picker, and select Configure Tools. Enable the Playwright tools needed for this request. Keeping the tool set focused makes it easier for the model to choose correctly and reduces unnecessary context. If organization policy disables MCP or agent features, the workspace file alone cannot override that policy. Test the connection with a read-only prompt. Use Playwright to open the local commerce lab and report the page heading, number of products, and accessible name of the search box. The agent should invoke Playwright, not infer the answer from index.html. Expand the collapsed tool call summary to inspect what ran. If the server is missing, return to mcp:/list servers and choose Show Output. Common causes are an unavailable npx command, a server that was not started, a trust decision where Visual Studio Code presents one, or launching Visual Studio Code in a remote environment while the server is configured locally. Workspace.mcp.json belongs in source control because it contains no secrets. Sensitive values should use supported input variables or environment handling, never hard-coded JSON. With the connection verified, Copilot's agent can combine editor context, terminal commands, and live browser evidence in one workflow, while every proposed code change remains visible for review. The most effective Visual Studio Code workflow keeps browser evidence, code changes, and test results in one reviewable loop. Begin with the Commerce Lab server running and the Playwright MCP server shown as started. In Chat, select Agent, open Configure Tools, and enable Playwright plus the editor and terminal tools required for this task. Then make the prompt bounded. Ask the agent to use Playwright MCP against the local URL, reproduce the discounted checkout, verify £19.99 before ordering, and summarize evidence. Tell it not to edit files yet. That last sentence separates discovery from implementation. As the browser moves, expand the tool summaries. You should see snapshots, interactions, and verifications tied to the current page, not a confident paragraph unsupported by tool calls. Capture a screenshot as supporting visual evidence, but keep the structured snapshot and assertions as the basis for interaction and verification. When the journey is complete, add the second request. Convert the explored flow into a maintainable case in tests/shop.spec.ts. Use role, label, and text locators, avoid sleeps, run the focus test, and show the exact result. Attach prompts/04 generate test.md as context if you want the repository's rules applied verbatim. Before accepting edits, inspect the diff. Look for a clear test name, stable test data, scoped locators, and assertions on business outcomes. In this application, the agent should not reach for a long CSS chain. It can target the shopping cart dialog, the discount code label, the status announcing 20% discount applied, and the exact £19.99 total. It should register the download listener before clicking the receipt. Run the focus test from the integrated terminal. If it fails, ask the agent to explain the trace and assertion error before proposing another change. The Problems panel is useful for TypeScript diagnostics, but a clean Problems panel is not proof that a browser journey works. After the focused pass, run npm test and inspect the HTML report. Accept or discard individual edits rather than treating the entire agent response as one transaction. This workflow is also where tool restraint matters. A request to edit a test does not require unrestricted browser profiles or unrelated services. Disable tools that are outside scope, review command approvals, and stop if the agent attempts a real purchase or leaves the local origin. Visual Studio Code supplies a convenient surface, but the engineering contract remains unchanged. First establish observable behavior, then write the smallest maintainable test, and finally prove it with an independent runner. The browser is the evidence source, the diff is the proposed change, and the green suite is the verification. Playwright MCP and Playwright Test both benefit from accessible page semantics, but they use them in different ways. MCP begins with an accessibility snapshot, a structured tree containing roles, accessible names, text, and temporary element references. In our Captured Commerce Lab snapshot, the page exposes a heading called Course Equipment, a search box called Search Products, Product Articles, and Add to Cart buttons. The model can pass a reference such as E84 to browser type. That reference is valid only for the current page state. Navigation or a DOM update can produce a fresh snapshot and new references, so never paste MCP refs into a committed test. Most browser actions return an updated snapshot automatically, and you can request browser snapshot whenever you need to reorient the agent. Test code uses locators that resolve against the live page whenever an action or assertion runs. Prefer page.getByRole for interactive controls and landmarks, usually with an accessible name. Use getByLabel for form fields and getByText for visible non-interactive content. In the catalog, several buttons share the name Add to Cart. We first locate an article and filter it with HasText Playwright Field Guide, then ask that article for its Add to Cart button. In a dialog, scope the next locator to the dialog. These boundaries make intent explicit and prevent a strictness error caused by multiple matches. Locators are central to Playwright's auto-weighting and retry behavior. When the interface re-renders between operations, the locator finds the current element again. Long CSS and XPath chains encode the present DOM shape and tend to break during harmless layout refactors. Test IDs are a valid, explicit contract when user-facing semantics cannot identify a target, but do not use them automatically when a meaningful role or label already exists. Also avoid first or nth merely to silence ambiguity. If two elements match, improve the contract or scope to the correct region. There is an important accessibility caveat. A role locator exercises the same role and accessible name information used by assistive technology, which provides useful early feedback. It does not constitute a complete accessibility audit or prove compliance. You still need dedicated automated checks and human assessment for keyboard operation, contrast, focus order, and the wider experience. For visually rendered content such as canvas or charts, a screenshot can complement the snapshot, and optional vision tools can act by coordinates. For ordinary forms and commerce controls, snapshot refs are more deterministic. The maintainable pattern is therefore snapshot to understand, reference to explore, locator to encode, and web-first assertion to prove. Good accessible HTML improves the application for people and gives our browser automation a stable, user-centered vocabulary. Core Playwright MCP can navigate and interact, but testing specific tools are opt-in. Our server enables them with --caps equals testing, alongside the other required groups. The testing capability exposes 4 direct verification tools and 1 locator generator. Browser verify element, visible checks an element by role and accessible name. Browser verify text, visible checks, visible text. Browser verify list, visible checks an accessible list and its expected items. In the verified server build, the element and list helpers are presence-oriented and emit candidate expect to be visible code. Do not mistake that generated suggestion for an independently executed Playwright test visibility assertion. Browser verify value compares the value of a referenced form control. Browser generate locator takes an element reference from the current snapshot and returns a Playwright locator suitable for test code. Use these tools to make an exploratory session accountable. After opening Commerce Lab, verify the heading course equipment rather than merely observing that the navigation succeeded. Search for Playwright, then verify the text "one product shown." During checkout, verify 20% discount applied and £19.99 before placing the order. After submission, verify the confirmation dialog and its labby order identifier. Each check turns an agent's claim into an explicit comparison with current browser state. Locator generation bridges exploration and code. Take a fresh snapshot, identify the exact add to cart reference within the Playwright field guide article, and call browser generate locator. Treat its output as a strong starting point, not an unquestionable final answer. If it returns a locator that is only unique because of the current page arrangement, scope it to the article or dialog before committing it. Temporary snapshot references must not appear in the TypeScript file. The verification tools also do not replace Playwright test. They validate the live MCP session, while a test file gives you fixtures, isolation, retries, projects, reporters, traces, and execution in continuous integration. When converting the flow, translate the important verification steps into web-first expect assertions, such as to be visible, to contain text, and to have text. Do not assert every transient detail. Select outcomes that define the business rule. Capability selection deserves deliberate thought. Core is always enabled. Adding testing expands the tool schema available to the model. Adding every possible capability to every server can increase context and give the agent more choices than the task needs. A discovery client may need only core. This course enables testing because we are deliberately moving from exploration into regression code. The practical rhythm is interact, verify, generate a candidate locator, write the test, and run it independently. If the agent says the checkout passed, but cannot show the total, confirmation and receipt evidence, the task is not complete. Assertions are how we replace plausible narration with verifiable browser facts. Modern browser behavior is often determined by the network, so a screenshot alone is weak evidence. Playwright MCP can list requests through browser network requests as part of core. Request mocking, route management, and online or offline control require the network capability. Start Commerce Lab, search for Playwright, and ask for network requests filtered by API. You should see a get to /API/products with search and category query parameters. During sign-in and checkout, the important calls are post/API/login, post/API/discount, and post/API/orders. The verified server prints a number beside each request. Use browser network request with that number when you need its headers or body. Inspect sensitive details only when the investigation requires them, and avoid echoing real authorization values into chat. Now, isolate the front end from the real product's response. Use browser root with the pattern **/API/products $** status 200, JSON content type, and a body containing one product named mock agent kit. Reload the page and take a fresh snapshot. The catalog should display that one mocked product without any application code change. Use browser root list to prove the interception is active, then browser unroot with the same pattern to remove it. The committed test expresses the same idea with page.root before reload. It fulfills a JSON response and then asserts the mock agent kit heading and £42 price. Mocking is excellent for empty states, server errors, and rare data, but it proves how the front end handles your invented contract. Keep integration coverage against the real local endpoint as well. For request evidence, the order test creates page.waitForRequest before clicking Place Demonstration Order. It then checks that the URL ends in /API/orders. The authorization header contains the course's demo token, the item and quantity are correct, and the post code was serialized. Again, register the waiter before the action that triggers it. Finally, test loss of connectivity. Call browser network state set with state offline, reload, and inspect the rendered error. Commerce Lab reports that products could not be loaded because its initial fetch fails. Restore state online, reload, and verify the 6-product catalog returns. Always restore the environment, otherwise the next chapter begins with a misleading failure. Network routes are scoped to the current browser context, and isolated mode helps prevent one lab's mocks leaking into another session. This chapter's method is observe the real request, change one network condition, verify the user visible consequence, then remove the condition. That sequence distinguishes a tested failure mode from a browser that simply happened to look right. Authentication is where convenience and security most often collide. Commerce Lab keeps its demonstration user and token in local storage, so the behavior is easy to inspect. These are deliberately public local credentials, not a model for production authentication. Our MCP configuration enables the storage capability and launches with isolated. In isolated mode, closing the MCP browser discards that session. The server's default persistent profile mode behaves more like a normal browser and can retain login state across sessions. For a course that repeatedly resets known test data, isolation is the clearer default. Sign in as the learner, then use browser local storage list. You will see the course cart, user and token keys. The storage capability can also manage cookies and session storage. To preserve cookies and local storage authentication state, call browser storage state with the file name artifacts/playwright mcp/learner storage state.json. In the server version verified here, that file contains cookies and local storage and is written to the ignored artifacts directory we named. In a later isolated session, call browser set storage state with the same project relative file name before navigating, or start the server with -- storage. State equals artifacts / Playwright MCP / learner storage state.json. Navigate to the application and verify the account button reads Alex and the page announces signed in as Alex Learner. Restoring state is not proof that the session remains authorized forever. The server may expire or revoke it, so always verify an authenticated page outcome. Treat the state file like a secret. It may contain bearer tokens or cookies that grant account access. Keep it out of source control, logs, prompts, and video. This repository ignores artifacts / Playwright MCP and .auth for that reason. Use a dedicated test account with the least privilege available and regenerate state when credentials or session policy changes. To test logout or first-time behavior, clear the relevant storage or create a fresh context rather than editing the file by hand. The committed suite takes the stricter approach. Before each test, it clears local storage and signs in only when the scenario requires authentication. Larger suites often create an authenticated setup project and reuse a protected storage state file for speed, while retaining separate unauthenticated coverage. Finally, be cautious with browser extension mode, which can connect MCP to existing tabs and logged-in sessions. That is convenient for trusted personal workflows, but it can expose real account data to the agent and to page content. Do not use your everyday profile for an untrusted site or demonstration. The safe pattern is dedicated account, isolated context, ignored state artifact, minimal permissions, and an assertion that authentication actually worked. Reuse state deliberately, never invisibly. Before we give an agent more browser access, we need to choose the right browser identity. Playwright MCP supports 3 useful patterns, and they solve different problems. The first is a dedicated persistent profile managed for automation. It can retain cookies and local storage between sessions, which is convenient when a workflow must stay signed in. The second is an isolated browser context. Our course configuration deliberately passes the isolated flag, so every run begins without an inherited personal session. That is ideal for repeatable demonstrations and for testing authentication from a known starting point. The third pattern is extension mode, which connects the MCP server to a compatible Chrome or Edge browser through the Playwright MCP extension. Extension mode is valuable when the task genuinely requires a browser that you have already opened, but it also exposes the state of that browser. Treat it as an explicit access decision, not as a shortcut you enable everywhere. In this repository, open the Codex configuration and notice the isolated flag, the fixed 1440 by 900 viewport, and the dedicated output directory. The same choices appear in the project-level MCP file and the VS Code configuration. Keeping them aligned means the demonstration behaves consistently across Codex, Claude Code, and VS Code. Record the profile choice in the project README so teammates inherit the same boundary. Now compare that clean start with the signed-in evidence already captured in the course. The file named mcp-signedin.png shows the visible authenticated state, while mcp-signedin-snapshot.iml records the structured accessibility view used by the agent. The important lesson is that authentication state is deliberate. We signed in with local demonstration credentials. We did not borrow a personal browser profile. If you need reusable authentication, create a dedicated test account and export an appropriate storage state for that environment. Remember that a storage state file may contain cookies or tokens, so exclude it from source control and rotate anything exposed accidentally. For a one-off exploratory task, isolated mode is the safest practical default. For a long-running test account, use a dedicated automation profile with narrowly scoped access. Choose extension mode only when an existing interactive browser is truly part of the requirement, then close the connection when the task is finished. Never attach an agent to a personal profile containing email, banking, or production administration sessions. A profile is not merely a window theme, it is an identity boundary containing valuable session material. The right choice gives us repeatability, reduces accidental data exposure, and makes failures easier to reproduce. In the next chapter, we will preserve the evidence from those reproducible runs using traces, video, screenshots, and PDF output. A browser agent saying that a task passed is not evidence. We want an inspectable record that lets another engineer understand what happened. Playwright gives us several complementary evidence types. A screenshot captures one visual moment. Video shows the sequence and timing. A trace combines actions, DOM snapshots, network activity, console information, and source context in an interactive timeline. An HTML report organizes the test result. A PDF preserves a printable page when that is genuinely the artifact the workflow requires. Each answers a different question, so avoid treating one screenshot as proof of an entire journey. Start with our Playwright configuration. Trace is set to retain on failure, screenshots to only on failure, and video to retain on failure. Those settings control the test suite and keep normal runs lightweight. Our recording script separately starts tracing around 2 planned demonstrations, which is why the repository contains a successful checkout trace and a network recovery trace, even though neither is a retained test failure. Open the checkout trace with npx playwright show trace production, captures, wendro2 checkout, happy path trace.zip. In the timeline, select the order submission. Inspect the page snapshot before and after the action, the request sent to the local order endpoint, and the confirmation dialog containing the generated LAB identifier. That chain is stronger than a narration claim because the UI and network evidence agree. Next, open the recovery trace. The first order request receives HTTP 503. The page exposes a useful alert. The root override is removed, and the same browser state succeeds on retry. The matching WebM recording makes the recovery easy to follow, while the trace makes it diagnosable. For test suite failures, run npm test, then use the HTML report and any retained artifacts attached to the failed test. Do not switch everything to always on in a large CI suite without considering storage, upload time, and sensitive page content. Evidence can contain user data, tokens, addresses, or downloaded documents. Apply retention rules and access controls. Screenshots are excellent for layout regressions and communication. Video is excellent for motion, timing, and reproducing an intermittent path. Traces are usually the best engineering diagnostic. PDF output is useful for receipts, invoices, or print layouts. Enable the Playwright MCP PDF capability only when the scenario needs it, save output to the dedicated artifact directory, and assert the underlying business state as well. A beautiful PDF does not prove that a payment request was correct. Our rule is simple: capture enough evidence to support the claim, and no more sensitive data than the team needs. With evidence under control, we can now examine when the agent should use structured page data and when it truly needs visual reasoning. Playwright MCP is powerful because it does not need to guess where ordinary interface controls are. Its core workflow can inspect a structured accessibility snapshot, identify meaningful elements, and act using stable references. That is very different from treating the page as a flat image and clicking a coordinate. Open MCP accessibility snapshot.yml from the course captures. We can read headings, buttons, regions, labels, and user-facing names from the local shop. After sign-in, the second snapshot exposes the authenticated text and the available controls. This structured representation is compact, explainable, and closely aligned with the role and label locators used in our test file. For accessible web applications, it should be the first choice. Ask the agent to inspect the snapshot, locate the control by its purpose, perform one action, and verify the changed state. You get a more deterministic workflow and a clearer reason for every click. Vision is an optional capability, not the default solution to every browser task. It becomes valuable when the important content is genuinely visual or has no useful accessible representation. A canvas drawing tool, a map, a chart rendered without semantic data, a remote desktop surface, or a control whose accessible implementation is defective. Screenshot capture is already a core tool. Enabling the vision capability adds coordinate-based mouse actions, which a vision-capable client can combine with screenshots. Coordinates can be necessary, but they are more sensitive to viewport size, responsive layout, overlays, and animation. That is why our configuration fixes the viewport and deliberately enables testing, network, storage, and developer tools capabilities without vision. Every step in the core course application can be completed through semantic structure. Consider the product search. The snapshot exposes a search box named Search Products, the result count, the Playwright Field Guide article, and its Add to Cart button. The agent can state exactly which elements support its plan. The matching test uses getByRole and getByLabel, so exploration and long-term automation share the same user-facing model. If a visual-only chart were added, we would first look for an underlying table or API response. If neither existed, we could enable vision for that narrow task, take a fresh screenshot, keep the viewport stable, act once, and then verify the outcome through DOM, network, or application state. Do not let a successful coordinate click become the only assertion. Vision also does not solve poor security boundaries or ambiguous requirements. It simply adds another observation and action surface. Prefer accessible structure because it improves automation and the product itself. Escalate to vision when the page demands it, constrain that use, and return to deterministic assertions as soon as possible. This hybrid approach is both practical and auditable. Semantic tools for normal interfaces, visual tools for genuinely visual surfaces, and evidence after every meaningful state change. Reliable browser automation starts before the first tool call. A weak prompt says, "Test the shop," and leaves the agent to invent scope, data, and proof. A strong prompt defines the environment, goal, constraints, evidence, and stopping condition. The prompts folder in this repository gives us 5 reusable examples. Begin with Explore and Plan. It names the local URL, requests an accessibility snapshot, forbids order submission, groups the proposed coverage, and asks the agent to cite the evidence behind each recommendation. That last instruction prevents a generic test plan detached from the actual application. The complete checkout prompt then supplies authorized local credentials, identifies the product and discount, states the required total, limits the order to a demonstration, and demands UI, network, and download evidence. Notice the progression. Inspect first, make one meaningful state change at a time, verify it, then continue. Good prompts describe outcomes in user language. Ask to sign in and verify signed in as Alex Lerner, rather than prescribing a brittle CSS selector. Ask to prove the total is £19.99, rather than merely click apply. Give deterministic test data and clearly label it as safe local data. Add negative constraints such as do not submit yet, do not change application behavior without approval, and do not claim success without checking each outcome. The debug failure prompt is equally important. It tells the agent to reproduce, inspect DOM, console, network and trace evidence before editing code, identify the smallest defensible root cause, and propose a regression assertion. This reduces the familiar failure mode, where an agent changes several files to make a symptom disappear. The generate test prompt turns exploration into a maintainable Playwright test. It requests role, label and text locators, forbids fixed sleeps, requires business assertions, and asks for the exact test command and result. Finally, the security review prompt keeps secrets out of the response and separates convenience choices from security guarantees. Use a simple prompt pattern for your own work. Context, objective, authorized data, constraints, evidence, output format, and stop condition. For long journeys, split discovery, execution, and code generation into separate turns. Let the agent report uncertainty instead of forcing completion. Name the files it may edit and require a diff review before broad changes. When a prompt depends on current page state, ask for a fresh snapshot rather than relying on memory. And when success matters, define it in observable terms. Our checkout is complete only when the discounted total, confirmation identifier, order request, and receipt availability agree. A precise prompt does not remove judgment, it channels judgment towards evidence. That is how we move from impressive browser movement to a workflow the team can review, repeat, and trust. Now the critical warning: Playwright MCP is not a security boundary. It drives a browser on behalf of an AI client, and the pages it reads may contain untrusted instructions. A malicious page can display text designed to manipulate an agent, just as an untrusted document can contain prompt injection. The MCP server can also expose powerful actions over browser sessions, cookies, downloads, network traffic, and files deliberately made available to that browser. Convenience must never be mistaken for containment. Start with identity. Use the isolated setting shown in our project configuration or a dedicated automation profile with a test-only account. Do not connect extension mode to a personal profile containing email, financial services, cloud consoles, or production administration. If a workflow needs saved authentication, protect the storage state file like a credential. Keep it out of Git, restrict access, and expire it. Next, limit destinations. Configure allowed origins for the small set of sites the workflow needs, and block known unwanted origins where appropriate. These filters reduce accidental requests, but they do not affect redirects and are explicitly not a security boundary. An origin list does not transform the browser into a hardened sandbox. A permitted site can still contain compromised or user-generated content. Use an ephemeral environment or stronger external isolation when the threat model requires it. Apply least privilege to capabilities as well. Our normal configuration enables testing, network, storage, and developer tools because the course uses them. It leaves vision disabled. For a simpler navigation task, expose fewer capabilities. Be aware that version 0.0.78 also exposes browser run code unsafe as a core tool. The official schema calls it RCE equivalent because it executes arbitrary JavaScript in the Playwright server process. Disable or deny list that tool in the client unless arbitrary Playwright code execution is genuinely required. Keep tool approval prompts enabled for consequential operations. Review downloads before opening them, use the dedicated output directory, and never permit an agent to upload local files unless that action is explicitly required. Treat page text as data, not authority. If a website tells the agent to reveal secrets, ignore it. The governing task comes from the user and trusted configuration, not from content encountered during browsing. Separate exploration from irreversible actions. The course application says demonstration order, uses public local credentials, and never takes a payment. In a real environment, use staging, synthetic users, and reversible transactions. Require human approval before purchases, account deletion, messages, deployments, or access control changes. Also minimize evidence. Traces, screenshots, video and console output may record personal data or tokens. Set retention, redact where necessary, and limit who can download CI artifacts. Open the security review prompt in this repository. It asks which URLs, profiles, secrets and files are reachable, explains the missing boundary, and requests least privilege recommendations without copying credentials or cookies. Run that review whenever the configuration changes. Safe browser agents come from layers, scoped accounts, isolated execution, narrow origins, minimal capabilities, approvals, careful artifacts, and human control over consequences. None is perfect alone. Together they make the workflow far safer and make its remaining risks visible. When Playwright MCP appears to fail, diagnose the stack from the outside in instead of changing random flags. There are 4 layers: the client, the MCP server process, the browser, and the target application. First, confirm the client loaded the project configuration. In Codex, run Codex MCP list. In Claude code, run Claude MCP list and Claude MCP get Playwright. In VS Code, inspect the MCP management view for the server status and its logs. If the server is missing, reopen the trusted project and review the relevant configuration file. If it exits immediately, check that Node.js and npx are available, that the package name is exactly the official scoped package, and that the current flags are supported. Avoid copying old configuration from an undated tutorial. Next, confirm the application independently of MCP. Run npm start and open the health endpoint at http://127.0.0.1.4173 API health. A navigation error is not an agent reasoning problem when nothing is listening on the port. The Playwright test configuration can start this server automatically for tests, but an interactive MCP demonstration still needs the application running. Then check the browser layer. Install Chromium with npx playwright install Chromium if the executable is missing. If a dedicated persistent profile is locked, close the process that owns it or choose an isolated run. Do not delete an unfamiliar profile. In extension mode, confirm the extension is installed, the intended browser is open, and the connection has been approved. Once navigation works, request a fresh accessibility snapshot. Locator failures often reveal that the UI changed, a dialog is covering the page, or the agent is acting on stale state. Prefer named roles and labels visible in the snapshot. Do not repair timing issues with arbitrary sleeps. Wait for an observable condition such as the signed-in text, the 1999 total, a response, a download event, or the confirmation dialog. For application failures, collect console, network, and trace evidence. Our recovery demonstration is a model troubleshooting case. The order route deliberately returns 503, the interface shows order service is temporarily unavailable, the trace records the failed request, and removing the route allows the same browser session to succeed. Open the recovery trace and establish whether the fault is test code, application code, environment, or test data before making a change. If CI alone fails, compare node and browser versions, environment variables, work account, and server startup logs. The workflow uses Node 20, installs Chromium with system dependencies, and runs one CI worker through the configuration. Finally, reduce the case. rerun one named test, preserve the first useful failure, and report the exact command, error, and evidence path. Systematic troubleshooting turns MCP from a mysterious black box into 4 ordinary components that can each be verified. Playwright MCP, command line automation, reusable agent skills, and Playwright test overlap, but they are not interchangeable. Choose the smallest tool that fits the job. MCP is strongest when an agent needs a live, persistent conversation with the browser. Inspect an unfamiliar interface, follow changing state, examine accessibility, network and console evidence, recover from an unexpected page, or ask clarifying questions during a long workflow. Its structured tools make browser actions visible to Codex, Claude code, or a supported VS Code agent. That richness carries context and tool call overhead, so it is not automatically the most efficient way to run a known sequence thousands of times. A command line workflow is excellent when the action is already understood and can be expressed as a concise script or direct Playwright command. Agent skills add versioned instructions and conventions, so a coding agent knows how your team prefers to launch, inspect, test, and report. In coding-heavy workflows, a CLI plus a focused skill can use fewer tokens because the agent works through files and compact command output rather than keeping every browser operation in the conversation. Playwright test remains the correct home for durable regression coverage. It gives us fixtures, assertions, retries, parallelism, reports, traces, and CI integration. Look at our course workflow. We use MCP to explore the local shop and prove the checkout interactively. The agent reads the accessibility tree, observes the discount response, and validates the receipt. We then convert that discovered journey into tests, shop.spec TS, where the locator and business assertions are explicit. From that point onward, npm test is faster, repeatable and reviewable. GitHub Actions runs the suite without an AI model deciding each click. This suggests a practical pipeline. Explore with MCP when uncertainty is high. Capture what you learn in prompts, documentation, or a reusable skill. Codify stable behavior in a Playwright script or test. Run it through the CLI locally and in CI. Return to MCP when the interface changes, a failure needs rich investigation, or a new journey must be discovered. Do not use MCP merely because the acronym is fashionable. Do not use a rigid script to explore an unknown interface. And do not let an agent's successful one-off run replace a regression test. The same security principles apply across the choices. Isolate accounts, protect state, constrain targets, and review consequential actions. In this repository, the prompts folder is the reusable instruction layer, the MCP configurations are the interactive connection layer, the test file is the executable specification, and the workflow file is the unattended verification layer. Together they form a clean progression from human intent to agent exploration to deterministic engineering evidence. That combination is more valuable than arguing for one universal interface. Let us finish by assembling the entire course into one professional workflow. Clone the companion repository, install dependencies with npm install Chromium, and start the deterministic application. Confirm the health endpoint before inviting an agent into the browser. Review the project-level MCP configuration for your client, then start the official Playwright MCP server. Keep the isolated browser, fixed viewport, scoped capabilities, and dedicated output directory unless your task has a documented reason to change them. The capstone begins with discovery, not clicking. Use the Explore and Plan prompt to inspect the accessibility snapshot, identify the main journeys, and rank smoke, negative and edge coverage without submitting an order. Review that plan. Then use complete checkout with the public local credentials. The agent must sign in, locate the Playwright field guide, apply MCP 20, prove the total is $19.99, complete the demonstration order, verify its LAB identifier, and confirm that the receipt is downloadable. Ask for UI, network, and download evidence. You can compare the result with the genuine checkout recording and trace in the production captures folder. Next, introduce a controlled failure. Route the local order endpoint to return HTTP 503, verify the accessible error, remove the route, and retry. The recovery recording and trace show the expected sequence. This is the moment to practice diagnosis. Observe first, identify the responsible layer, and preserve evidence before editing anything. Once the journey is understood, use the generate test prompt to codify it. The repository's test suite demonstrates search and cart behavior, invalid authentication, discounted checkout and receipt download, a mocked product response, and order request payload assertions. Run npm test and inspect the HTML report. The test configuration records a trace, screenshot, and video when a failure requires them. Finally, push the branch and let GitHub Actions provide an independent environment. The workflow checks out the code, sets up Node 20, restores the npm cache, installs exact dependencies with npm CI, installs Chromium with operating system dependencies, and runs the suite. It uploads the HTML report even when a test fails, and retains it for 14 days. Review the report before merging. A green badge is a signal, not a substitute for understanding the assertions. You now have the complete pattern: constrained browser access, structured exploration, evidence-driven prompts, maintainable tests, and repeatable CI. Use MCP for uncertainty, Playwright test for permanence, and least privilege everywhere. The source repository, prompts, configuration, traces, and recordings linked below are designed to be run, inspected, and adapted. If this course helped you build a real workflow, share the specific browser journey you want covered next, and subscribe for the follow-up on production-grade agent testing. Most importantly, open the repository and run the Capstone yourself. Reliable automation is learned by observing the evidence, not by watching a cursor move.